Okay, it looks like we have everybody that's going to log on for right now. Some might join us later. So let's go ahead and get started. We've got a fantastic lineup of speakers today. So welcome to the OWCN lecture series number 5. We're glad that you're here today. Again, this is the 5th of our 6 lecture series that we've offered for the network. And this one is going to focus on southern resident killer whale oil spill planning and some information post the Deepwater Horizon. So we'll get to that in just a minute. So again, thank you for being here today. Again, this is the 5th of the 6 lecture series. So today, May 13th, 2022, we're going to talk about marine mammals. We have one more lecture series coming up on June 6th, and that is going to focus on species prioritization and resources at risk. For those of you who don't know me, I'm Denise Bertel, and I am the Readiness Coordinator for Care Operations. And I'll be acting as your host today for this 1-hour lecture series. A little bit about our agenda. So right now we're in the welcome portion of our agenda. After we get through just a little bit of logistics, we're going to hear about reducing the risk to southern resident killer whales from oil spills. And then we'll have a brief Q&A. And then from there, we'll move on to findings from the Deepwater Horizon Marine Mammal Injury Assessment. And then we'll have a Q&A and another closing. But before we get to that, let's just talk a little bit about your Zoom controls for today. We are in the webinar setup today. So you may not have control, or you will not have control over your audio settings, but if you're going to speak, we will be able to unmute you if we need to talk to you during the Q&A session. We invite you to use the chat, which is probably on the lower toolbar, or at least on the upper toolbar, wherever you have your toolbar. Please say hello to each other, introduce yourself, connect with somebody you haven't seen in a while or heard from in a while. So please use the chat. We also invite you to use the Q&A during the presentations. If you have a question that comes up or a question that you'd like to ask either the OWCN management team or one of our speakers, please use the Q&A. Some questions we might be able to answer in real time, and some we will hold for our speakers. And finally, if you need to leave the meeting before the meeting is over, you just use the leave meeting button. And from there, you'll be able to exit the meeting. We are also recording today's session. So we're currently recording. And if you know anybody from the network who was unable to be here today, we will be posting a password protected recording that we will share with you all later. So with that, I'm going to stop sharing. And I'm going to introduce our first speaker. So our first speaker today is Grace Ferreira, and Grace is here from NOAA Fisheries. And Grace is going to talk to us about reducing the risk to southern resident killer whales from oil spills. So Grace, I'm going to turn it over to you.
Thank you. Here, I'll share my screen. Okay.
Looks great.
All right. Awesome. Thanks. Well, good afternoon, everyone. My name is Grace Ferreira, and I'm our acting southern resident killer whale recovery coordinator for NOAA Fisheries. I work in Seattle, Washington, and today I'm going to give an overview of our oil spill response planning that we've done for southern resident killer whales. So just to kind of orient us in case anyone isn't familiar with southern resident killer whales, I'll give a little bit of background. So this is a very small population that lives on the west coast of the United States. They can be found in stable family groups, and there are 3 pods of southern resident killer whales, J, K, and L pod. And these are fish-eating killer whales. Their main prey item is Chinook salmon. We also in Washington have transient or Biggs killer whales that are the marine mammal eaters, but that population is not listed. These killer whales rely really heavily on sound. They use echolocation to find food and to navigate, and they also use sound to communicate with each other. They're a very social species, and they have distinct dialects that they can use to communicate with each other as well. And individuals can be identified by the distinct markings on their body, as well as their saddle patches, which is that white patch behind the dorsal fin. It's different for every whale. It's kind of like a fingerprint, and so we can use those to identify individuals. This population experienced a really significant decline in the 1990s. We saw this about 20% drop in just a few years. And so we received a petition to list them shortly after that. And we listed them as endangered in 2005. And then we spent the next 3 years developing our recovery plan for them. But as you can see, their population, while it's fluctuated a little bit, is still kind of continued to decline overall. So at the end of last year, there were 73 individuals in the population. Fortunately, this year we have had 2 calves born, and so that number has been brought up to 75. So our recovery plan establishes a really broad approach to address all of the threats posed to this species. And while there are 3 main threats, those are prey availability, impacts from vessels and noise and contaminants, we also identified the risk of an oil spill as a really serious concern. As we all know, these small endangered populations are really vulnerable to stochastic events. And because they tend to travel in these family groups of, multiple individuals, an oil spill could have really severe consequences to the population as a whole. That kind of event could impact a large proportion of the population all at once. Southern residents are also at high risk because, or they're more vulnerable because of their proximity to high risk areas. So as you can see from this graph or this map of Washington, we designated all of the inland waters of Washington as critical habitat in 2006. That green area around the San Juan Islands is particularly important. That's their core summer foraging area. Historically, the whales have spent quite a bit of time there, and so that's really important to them. We did also designate areas of their coastal range as critical habitat last year. It took us a little while longer to gather the data that we needed to figure out where exactly they were going and what they were doing in each area, and so that's why we didn't include that in the designation until last year. But there are 3 essential features of their critical habitat that are really important to their recovery and survival. And those are water quality to support growth and development, prey of sufficient quality, quantity, and availability to support growth and development, and then passage conditions to allow for migration, resting, and foraging. But in this kind of core summer critical habitat in the inland waters, we also have quite a few refinery locations, so that area in general is kind of high risk. For that reason, those facilities that store a lot of petroleum products are right around there. And then we also see quite a bit of vessel traffic in the area, and that poses the risk of kind of smaller spills, but also from the large oil tankers that carry petroleum products to and from these refineries. So this is why this is such a big concern for this population. As you all know, in the West Coast, the coast is divided into 2 geographic planning areas. So we've got the Northwest Area Contingency Plan and the Coastal Zone Plan in California. And both of those RCPs include wildlife response plans, but the Northwest Area Contingency Plan really focuses in on southern resident killer whales. And within our agency in the West Coast region, we developed this draft oil spill contingency plan. This was published in 2019, and it hasn't been finalized yet, mainly because of resource limitations. But this plan is a really great resource to kind of see an outline of all of our trust species and the programs that we've put in place to respond in the case of an oil spill. And then for southern residents, we have our killer whale hazing implementation plan, which is a really important document, and I'll explain why that is in the rest of this presentation. So killer whales, of course, are unlikely to be able to detect and avoid an oiled area on their own, so we kind of have to do that for them. So deterrence and monitoring activities are really the only mitigation measures possible during an oil spill, because capture and rehabilitation of killer whales is very difficult and just not likely to be carried out successfully. So in the case of a spill, our #1 priority is to identify where the whales are if they're in the area, and then to keep our eyes on them. So we want to make sure that we know where they are at all times and we keep track. We also ask our stranding responders, or our stranding network and our spill responders, to take as many photos as possible so that we can do that photo ID matching to determine who's there. That's, you know, for kind of long-term monitoring purposes, and then maintain all of that data in data logs throughout the response. And then if we determine that they might be heading towards an oiled area, we would use deterrence techniques or hazing to prevent them from entering the vicinity of the spill. So this is kind of our general strategy for killer whales. In the West Coast region, we rely really heavily on our marine mammal stranding network in the event of any number of accidents and disasters. They regularly support our marine mammal health and stranding response program by carrying out activities like live and dead animal response. They perform necropsies and collect samples for us, and they can also analyze and process those samples. And then they are the partners that hold the resources for rehabilitation and release. So one important role that they can play, in particular, in the event of an oil spill, is with wildlife reconnaissance. These organizations have spent countless hours observing marine mammals and their behavior, and they can help cite and identify them for us. And they also have the resources in many cases to provide ongoing aerial, ground, and on-water support of wildlife search and recovery efforts. The Stranding Network also already has a hotline established for public reporting, so they can help field some of those reports that we might get. And they also serve as the Marine Mammal Recovery and Rehabilitation Group. So they're kind of mobilized immediately if marine mammals of any kind are located in the area. And they've got some data collection and data management tools already set up for us. In addition to our Stranding Network partners, we also have relationships with a number of other organizations that can assist us. These partners have experience and expertise to provide sightings data on the water monitoring. They can carry out our deterrence activities for us, and they're also really important for education and outreach to the public on the scene, and helping us manage those interactions. These are just a handful of the partners in Washington State. They include other government agencies, NOAA science centers, tribes, NGOs, and academic institutions. So hazing activities during emergency oil spill response are authorized under an MMPA and ESA research and enhancement permit issued to the Stranding program. So we already have this permit in place, and that the authorization is there to be able to kind of mobilize those resources as quickly as possible. And specific deterrence or hazing methods recommended at the time of the spill really depend on the current conditions and the information that we're getting in the command center. So no one individual deterrence technique works in all situations, but the permit issued to the Stranding program pre-authorizes 3 methods in particular, and those are low-flying helicopters, Akami pipes, and seal bombs. Akami pipes are these long metal pipes that are extended into the water, and then they are hit with a metal mallet to produce a really loud sound. Seal bombs are underwater firecrackers. They're used in a variety of deterrence cases, but they have been pre-authorized for this in particular as well. So we're really looking at making a lot of noise to keep these animals that are so dependent on noise out of the area. Each of these methods carries their own risk to the animals themselves, but that risk is considered an acceptable alternative to the population-wide consequences of harm from oil. Other methods that might be used include vessels, using vessels to kind of herd or corral the animals, or spraying high volumes of water using fire hoses to keep them away from the area. Those methods are high risk enough that they have not been pre-approved. Those are situations in which we would really want to step in and consult and make sure that was a necessary and appropriate method to be used in that situation. So our killer whale hazing implementation plan outlines all of the factors that go into the decision of whether or not to deter the animals from entering an oiled area. This decision tree shows how we weigh the risk of the whales entering the oiled area against the risk of harm posed by the hazing methods themselves. And you might also notice that we've established this like 50-mile radius. That's the point at which we start making this decision, is if they hit that 50-mile mark. And then the risk of them actually entering the oil directly correlates to what methods we use. So you'll see that low risk category, we use the low risk deterrence methods, and those are the helicopters and the pipes. Those have the lowest likelihood of causing physical harm to the animals. And then as the risk of them entering the oiled area increases, we start using some of the other methods like the seal bombs or firecrackers, and then potentially vessels and the fire hoses. So in order for this to be successful, we really need to have proper staging of those hazing resources so that we can deploy them efficiently. That's something that we have struggled with, in particular with the Okami pipes. They're very large and difficult to transport, and having them staged strategically is important. We also need multiple vessels for each of the vessel-based methods. So for the Okami pipes, for example, the proper way to use them is to have multiple vessels in a line, deploy them to create kind of a curtain of sound. And then we need an additional safety vessel taking observations and making sure that we're following all of the safety protocols associated with it. So that's just kind of an example. It requires a lot of people and extra vessels than you might think. And then we also need to be taking continual observations of the animals. And that's true from the beginning, whether or not we deploy hazing methods, but in particular, we want to make sure that we track those individuals to make sure that there aren't any long-term effects. And if there are, that we've documented them so that we can learn from those experiences. So we do have to think about, what if hazing doesn't work? That is our kind of worst case scenario, of course. And if it doesn't work, we have really limited resources to capture and rehabilitate killer whales, especially given the fact that there's likely to be many of them impacted all at once. So we might be able to rehabilitate 1 or 2 animals, but probably not 5 or 10 or 15. So we really want to avoid getting here in the first place, of course. And our only options really moving forward are kind of long-term monitoring, and then stranding response if we start seeing dead animals washing up on shore, being able to dispose of them properly and perform necropsies and things like that. So we have all of our plans in place, of course, to avoid that scenario. But I think it's really, there's a few activities that we undertake regularly that are really important for us and help us stay prepared. And one of those is participating in these annual worst case scenario drills that are hosted by the refineries in Northern Washington. We haven't been participating in those during the pandemic, but hopefully, you know, as things are opening up, there will be more of those again every year. Those are just really helpful exercises, and we've managed to develop really good relationships with those facilities to be able to get invited and included, and to offer our support and advice to them. We also try to have regular training with our responders. This is something that we struggle with a little bit because our group of responders is so large. Those vessels of convenience and other kind of boots on the ground folks they have, you know, day jobs and they're doing other things, and they're not necessarily always ready with their vessel in the water to go respond. And it's kind of tough to get them all together for trainings. But our relationships with the Washington Department of Ecology and the Washington Department of Fish and Wildlife have been really helpful in this arena. So they have developed a training curriculum for the killer whale deterrence program. And they really are kind of developing those one-on-one relationships with responders and folks who have volunteered to be available in the case of a spill. So they're always kind of reaching out to partners to provide resources and to kind of build up our arsenal of tools. And then we also conduct annual or semi-annual resource updates. And those are updates to the resources listed and the contacts listed in the Northwest Area Contingency Plan, but also on the NOAA's Office of Response and Restoration website. That's usually where we keep our most up-to-date information. And then going through all of our stores of the tools like the Akame pipes and seal bombs to make sure that you know, everything is still in good condition and able to be utilized. And that's what I've got for you today. So I'm happy to take any questions.
Thank you so much, Grace. That was really, really interesting. I especially liked hearing about the hazing and deterrence methods that you guys have used. We do have a couple of questions that came in. So one is, can you use killer whale distress vocalizations to direct them away from the spill perimeter? She says that it could be less harmful than the seal bombs.
Mm-hmm. Yeah, that is one tool that we've considered. We don't know how well it works. So it's something that we can have in our back pocket for sure. And if I think we're looking at a lower risk situation where we think, you know, they're still far enough away from the spill, that's the place where we might have time to try out a few other methods first before having to resort to some of those more, you know, risky ones. We also, you know, people have to be trained to use the seal bombs. We don't just have anyone go out there throwing firecrackers at the whales. And so they know how far away they need to throw them and things like that. And certainly we wouldn't be trading off, you know, throwing a firecracker on a whale for the oil spill risk. But yeah, that's a good example of something that we might try to use in one of those lower risk categories.
Thank you. So another question that came in was, are the oil spill drills done as tabletops or on site with equipment mobilization?
There's a combination of those. So you more often than not, they're tabletop drills, but we still will be calling our list of responders and including them. So it's not just the people that are kind of in the room at the table that are participating in it. And that's a good opportunity for us to know at certain times of year, you know, whose boat is in dry dock and whose is in the water, and to keep track of those kinds of things by having us, you know, do those fire drills. And I think it's eye-opening for them, for the members of our response programs as well. And so that's been pretty useful. But yeah, we haven't had something that we're trying to plan is practice using the Akame pipes. We want to get those out there and try, you know, deploying them, probably without actually banging on them to generate the noise, because that is, you know, harassing all of the marine mammals that are in the area. But I think it would be really useful and something that I see as a big gap in our training and preparation.
Thank you. Okay, Marcel asks, how long would it take to get permission, and from whom, to use the higher risk hazing methods such as fire hoses? And a second part to this question is, have you ever had to rehab an oiled killer whale? How much does an RP have to pay if proven to be responsible?
Wow, yeah. So it's a very quick process. We've really streamlined all of the paperwork and everything that we need to fill out. And usually we will have someone in on the wildlife team, someone from the agency. So that's NOAA needs to provide the authorization via a streamlined Endangered Species Act consultation process. But it can take, I mean, it's very quick. So it's, you know, maybe an hour of making sure we just have the right signatures on the forms, but probably not even that long. So we would initiate that process before we would think we would need it, because it does take a minute. It also takes time to deploy those resources as well. So that, I think the more time limiting component of that is getting the resources in place. I have never rehabbed an oiled killer whale. Fortunately, we've never had to use any of these resources for Southern residents. So that's exciting. And I don't know how much the RP would have to pay for that. It's very expensive. We would have to transport the animal we have a net pen in Puget Sound that we can use as a holding area, but then they would need to be transferred to a facility that can house that animal. And right now our main partner for something like that would be SeaWorld. So that's, you know, a flight for like a, you know, freight flight for that animal, and then lots of money towards its care for probably, you know, several months. So it would be expensive for sure.
I would imagine. Okay, so Lindy says that she lives in Washington and she was wondering where she could sign up to volunteer as a responder or trainings.
Yeah, that's a great question. So the Department of Ecology has a website. If you just Google the Washington Department of Ecology oil spill program, it'll take you to their website, and there should be a link there where you can sign up. But if you can't find it, you can email me. It's my name, grace.ferreira@noaa.gov, and I can send you right to it.
Okay, another question. So with Humphrey, humpback and Sacramento River, we used okami and feeding calls to lure and acoustically push him seaward, basically using the carrot and the stick. Don't know which worked, but neither did when used alone. Do you have any comments on this?
No, that sounds, I'm not familiar with that case, but that sounds really interesting. And I think in a confined space like that, I feel like that's a good strategy.
Okay, any more questions? So Scott put in the chat a link to volunteer in Washington. Thank you, Scott.
Awesome.
Okay, I think that's it for questions. Thank you so much, Grace.
Great.
That was really terrific. It's so amazing to see how much effort you guys have put into oil spill planning for killer whales. And I'm sure we'll be reaching out if we ever have an incident that involves killer whales down here. So anyway,
Yeah,
thank you.
absolutely. Thank you so much for having me. Yeah, take care.
Yeah, bye. Okay, I'm going to turn it back over to Deneen, and she's going to introduce our next two speakers, Ryan and Forrest. Deneen?
Great, thank you, Kira, and thank you again, Grace. That was a fantastic presentation. So our next two speakers are going to share findings from the Deepwater Horizon Marine Mammal Injury Assessment. Let's welcome Ryan Takashita and Dr. Forrest Gomez.
Hey, everybody. My name is Ryan Takashita. We, both of us, work with the National Marine Mammal Foundation. I am the Deputy Director of Conservation Medicine and a research scientist. And Forrest, would you like to introduce yourself?
Sure. Hello, everybody. I am based in San Diego, and I'm a marine mammal veterinarian and serve as the Director of Medicine, and was one of the veterinarians on the health assessments following Deepwater Horizon.
Awesome. Forrest and I are going to tag team this. So I'll sort of tell you about some of the work that we did, kind of leading through the NERDA, and writing up the results for settlement and some of the toxicology work that we did. And then we'll have Forrest sort of dive into 2 of the very specific adverse effects so that we're not just kind of glossing over everything, but diving deep into a few things. First, we just really appreciate you all inviting us here today. We're excited to be a new partner with the network, and we're just excited to be working more closely with all of you. So thank you again. Before we get too far, I just wanted to say you can go to our website at nmmf.org. There you can find a lot more about the publications and the projects that we're talking about today. So I hope you'll go check out that site. Okay. And even though Forrest and I are the ones that are talking to you today, this work obviously was a huge collaboration with a ton of folks in the field, a lot of folks doing data analysis, coming together for workshops, expert elicitations. A lot of the work we'll tell you about is through the Consortium for Advanced Research on Marine Mammal Health Assessment. And that was funded through the Gulf of Mexico Research Initiative. And then some of the work was through the NERDA, which I'll introduce you to in a second. And another reason we're really excited to talk to you all is because so much of our work depends on the hard work that Stranding Network members put in, response folks, and our fellow researchers. So thank you to everyone on the call that made this possible. I'm sure many of you were involved in one way or another. So we were asked to sort of give a summary of the methods we used and what all we learned from the Deepwater Horizon oil spill and how it affected marine mammals. The work has spanned over 12 years now, and it was originally part of this NRDA, this Natural Resource Damage Assessment. And that's just the legal process through which the government, acting as our natural resource trustees, can hold polluters accountable for restoring any damages they've caused, just like the question about, how much would a polluter have to pay if a killer whale had to go into rehabilitation, right? But since the NRDA was settled in 2016, a lot of our work that we'll tell you about has been through that Karma and Gomri funding source. So much of the work came from looking at some of the more than thousands of dead carcasses that stranded during an UME following the spill. And then a lot of what we'll tell you about is from a series of live capture health assessments. These capture and release efforts, mostly in Barataria Bay with dolphins, but some outside of there. And then we extrapolated our work to other species of dolphins and whales. And so I'll try to touch on those whenever I can when we did those extrapolations. Okay, let's jump on in. So one of the many things we dove into during the NRDA especially is trying to link this whole pathway from exposure to effects to quantifying overall population level effects. And despite previous assumptions, when we combed through all the photographs and surveys, we realized that cetaceans did not avoid swimming in oil slicks. So this is something that we sort of had to actually establish when we got started. And since they don't avoid the oil, you can imagine that means that they can get exposed through a variety of different pathways, whether it's by breathing in vapors and aerosols, or even whole liquid droplets, whether it's incidentally ingesting via water or contaminated prey, or even dermal absorption or through the eyes. And once the animal is exposed, we had a variety of different ways to assess what the injuries were. And I won't go through all of this. I just wanted to kind of give you an idea of the breadth of different ways we approach the problem. So as we talked about with some of the stranded animals, You have your typical gross or histological necropsy and observational data that we could comb through with the suite of analyses from live dolphin health assessments. And then, of course, remote sampling and thinking about reproductive and survival rates through surveys and remote biopsies. So to take all of that and just throw it into one vastly oversimplifying slide, here are some of the documented adverse effects. And I think what was really cool about what we saw is that we were able to support our findings in by looking at the consistencies between both live animals and dead animals, right? And so, for example, we saw lung disease, and we saw that in ultrasounds of live captured animals and in histopath from the stranded animals. We saw impaired stress response. We saw low cortisol levels in dolphins during the health assessments, even though they are ramped up because of the capture and release process. And then we saw adrenal cortex thinning in the histopath results. Like I said, there was a UME, so we saw increased mortality, but we also supported that with photo ID surveys and calculating what we would have expected survival rates to be. And then Forrest will give us some more information about this low reproductive success rate, which we saw both in the field, but also in clinical diagnoses with animals in hand. So because this is probably very unsatisfying for you, I encourage you to go to this special issue of Endangered Species Research, where a lot of the results are, and then you can sort of follow the trail from the authors in that issue to see some of the more recent work we've done. But for helping decision makers with that settlement process of the NRDA, we had to pull together all of those findings and plug them into population models so that we really could try to quantify the effect on population numbers. So this is that red line here where we're modeling what the decline in the population of dolphins in Barataria Bay looked like, and then what the recovery will look like over time. And then we compare that to what the population in theory would have looked like if the spill had never happened and just stayed sort of constant. And so by comparing those two trajectories, we can now start to come up with some metrics like loss cetacean years, years to recovery, maximum population reduction, and start to put some numbers around, what is the effect, and therefore what should BP and the other responsible parties, be responsible for. Like I said, this is for Barataria dolphins, but we also extrapolated those results to all of the other cetaceans that were in the footprint of the oil spill, and we'll talk a little bit more about that later. So after the NRDA settled, when we were putting together what we wanted to do for Karma, one of the things we knew was happening is that there's all this other research going on into species, other than marine mammals, of course. And since, as we all know, toxicology research on vertebrates and marine mammals has a lot of entirely reasonable hurdles, ethical hurdles, financial hurdles, logistical hurdles. And so we wanted to try to leverage all of that other information from these other taxa so that we could apply it to what we are learning about marine mammals. So we held a workshop with a lot of really great toxicologists, biologists, veterinarians, resource managers. You might recognize this up and coming scientist from California that was invited. And our summary is here in this article in Journal of Toxicology and Environmental Health Part B. So I encourage you to go check that out. Okay, so between our studies, specifically on marine mammals, and our ability to make inferences from all those other taxa, we had a nice set of effects that we wanted to learn more about during Karma and during the other GOMRE studies. And so after the NRDA, we sort of said, okay, well, it seems like all these other taxa have some sort of cardiac effect. Is that something we can look at in the dolphins? And so I will cede the floor to my colleague from San Diego, who's going to sort of dive into that question and then give us a little bit more information about this reproductive failure effect that we saw. So first.
Perfect. Awesome. Thanks, Ryan. And hello again, everyone. Thank you for having us. Like Ryan said, I am going to give a brief kind of overview of two really large investigations that were led by the foundation's Dr. Lori Schwacke and Dr. Cynthia Smith to kind of dive deeper into the reproductive loss that was documented in Barataria Bay and to look more closely at the potential cardiac effects that maybe were impacting dolphins in Barataria Bay. And so to do this, we followed a research approach, which I have outlined here on this slide, that involved heavily on partnering with animals that live in managed care to refine reproductive and cardiac diagnostic techniques that we needed in order to really answer these questions. Once that first step occurred, we then applied these methods to wild dolphin populations in Sarasota, Florida, which is our reference population. And then of course, in Barataria Bay, the oil impacted area. And then finally, we did also retrospectively analyze reproductive and cardiac tissue from managed as well as oil impacted dolphins. You can go to the next slide, Ryan. Forgot I can't advance. Thank you, perfect. So this slide just kind of shows you using ultrasound as an example, what this methodology looks like. So again, working with animals under human care, we needed to, what that setting allows us to do is it gives us time, frankly, and we were able to refine the techniques that we needed to use in the field rapidly when you only have a short amount of time with a wild dolphin. And so for ultrasound, we kind of refined the techniques and practiced them in that setting and then took them to the field. And we can now conduct a full body ultrasound in about 10 minutes and an echocardiogram to look at the heart, as long as we have a board certified veterinary cardiologist, in about 5 minutes. Next slide, Ryan. So again, this is just a quick snapshot into these multi-year, multi-institutional large efforts. But for cardiac, you know, Ryan said there had been documented adverse cardiac effects in other species, including humans. And we had also noticed a high prevalence of heart murmurs when we were doing live animal health assessments. And so we wanted to investigate this further as a potential impact on marine mammals. Dr. Barb Linehan, who's in the photo on the left, my colleague, this was her postdoc work, and she really helped lead this charge, which involves standardizing auscultation. That had actually never been done before, just how you should listen to a dolphin heart, and the refinement of ECG use, echocardiography, and then we also, of course, involved histopathology and gross pathology to figure out what was happening. Next slide, Ryan. And so what did we see? Like I said, going into this, we hadn't documented cardiac disease. This was just trying to get the techniques down so that we could really look into it. And what we found is that Barataria Bay dolphins did have some evidence of cardiac disease, including significantly thinner walls and chambers and a higher prevalence of valve problems. And then additionally, we did diagnose pulmonary hypertension in 2 animals, so small sample sizes here, but it's still something that hasn't been seen before in wild dolphins, and it can be associated with chronic lung disease or pulmonary disease, or with oil cardiotoxicity, or both. And so it is it is an important finding. We also figured out through this work that bottlenose dolphins do normally have a high velocity flow murmur, which we don't believe is associated with disease. It's benign. But I also do like to point out that this work was done about 8 years after the spill. So it's difficult to say for certain whether this is indirectly being caused through chronic issues or directly through oil toxicity, or what's most likely is that it's a combination of these things. So again, tipping our hat to everyone that's on the line from Stranding Centers and highlighting how important it is to continue to do not only the live animal health assessments, but those dead animal studies. So all of that time in the Path Lab really does help us. Next slide, Ryan. For reproduction, again, quick overview of a huge effort where, again, we had to refine our diagnostics, and this include refining an ultrasound protocol for field use and improving blood-based reproductive biomarkers. That effort was led mainly by Dr. Ashley Barrett-Claw, also from the foundation. And then we looked into maternal oxygenation, and that effort was led by Dr. Sarah Sharp who is now with IFAW. And to do this work, we really did have to start with dams from managed care facilities where we had known medical histories. That way, these pregnancies were followed over time. A ton of information was known about the pregnancy, the dam, the fetus, and we had follow-up tissue from failed pregnancies. And that was the only way we could kind of synthesize all of this data to try to figure out why dolphin pregnancies fail and then apply that in the field. You can go ahead to the next slide, Ryan. So I'm not going to dive into this, but this slide just shows some of the ultrasound abnormalities that you can find in the placenta, in the mom, or in the fetus. And you can see from the percentages that we did see a lot more abnormalities in the failed pregnancies in Barataria Bay versus in the successful. Next slide. Again, the final step was to integrate a large amount of data that was collected both from Stranding Network as well as from live animal health assessments, ultrasound, blood work, other health data from physical exams in the field, outcomes. Our team goes out and follows these pregnancies over time to see if calves come out alive or not. And then of course, again, necropsy. Next slide. So our key findings for reproduction were that, not really surprisingly, 96% of pregnant Barataria Bay dolphins with a negative outcome did have evidence of maternal disease, which had been documented during the NERDA, and we more or less were able to show that this was contributing to fetal loss, or pregnancy loss, I should say. Some of the potential mechanisms, probably one of the main ones is placental dysfunction, which can be seen with a multitude of different diseases. We did document that in 65% of pregnant Barataria Bay dolphins. And we do think that there is probably a degree of low oxygenation or fetal hypoxia that's happening in utero with the fetus because of the lung disease that we have, the sustained lung disease that we have seen in this population over time. All right, back to you, Ryan.
Thank you, Dr. Forrest Gomez. So we just wanted to touch on that through line of how these health trends are, we're seeing this over quite a long stretch of time. It's been about 10 years, 11 years now since the spill. And unfortunately, we're seeing these adverse effects persisting and in some cases getting worse. We don't know if this is due to the exposed cohort getting older, just the nature of chronic diseases, maybe an accumulation of additional stresses on top of that impact from the oil spill. But it seems like some of these aspects just aren't going away. And then what is encouraging is that some of the Barataria dolphins that were born after the spill seem to mostly be okay. There's one exception where some of the calves do seem to have immune dysregulation that we saw with some of the exposed animals. And we're not really sure if that means that there's still some sort of ongoing chronic exposure, or if maybe there is some kind of maternal transfer issue. And we just do want to quickly note, this is important when you're thinking about restoration planning, that these compromised populations are going to be vulnerable to other threats, to other stressors. And so we just have to be really careful when we're designing restoration. Okay, so I'll fly through this because we're already running long, apologies. We updated our model, we added a whole cohort based on animals that never recover, which is not something that we expected when we first put the model together, along with updating various other demographic elements of the model. We also moved from a stage structured model to an age class sex model. We ran it through the computer, and here was the update. And so again, the blue line is what would have happened if the spill had never occurred, according to the model. And then the red is this fall and recovery. And so the maximum proportional decrease turned out to be estimated at about 44% of the Barataria dolphins were lost because of the oil spill. And we should be at about the bottom right now, about 10, 11 years after the spill. And it'll take 3 to 4 decades before this population recovers. We're in the process of publishing all of the other species, so we'll be happy to share that with the network when that paper gets put out here. Here's a whole list of things that we established. I will say for this group, one of the most important things we did is that now we have sort of a longer list of things that Stranding Network members and other researchers and responders can do to get a handle on some of these things that we now know oil can do to marine mammals. So that's a huge win. Of course, there's a lot more to do. One thing I'll touch on really quickly is just trying to think about how we can use these strategies for smaller events. There have been now a few oil contamination events off the coast of California, but they're not to the level where you'd put together the costs for an entire in-person live animal health assessment. So we need to start thinking about these remote assessments a little bit more. And one thing that OWCN is working on with our colleague Ashley Barrett-Clough is thinking about epigenetics and how samples like remote biopsy samples can tell us about the age of an animal and other parameters that might be going on in terms of the health of the animal and demographics. So with that, we'll say thank you again, and we will welcome any questions.
Thank you so much, Ryan and Forrest. That was really fascinating. And it just blows my mind to think of all the logistics involved in a study of this magnitude. It's pretty remarkable. So just a reminder to drop your question into the Q&A if you have any questions. So we have one question so far. It says, was the lung disease from inhaling fumes, or did you find anthracosis from exposure to particulate matter from in situ burning? That may take longer to develop. She also says, Moat Marine Lab has done some studies on the Bonos in Tampa Bay on anthracosis from industrial particulates atomized by wave action.
It's super interesting. Yeah, I don't think that we were in a position to collect those data, unfortunately. And so the best we can do is sort of think about what the exposure would have looked like and just kind of characterize it at a qualitative level. And I think it could be all of those things. I think the question is exactly spot on. I think we ended up focusing a lot on that aspiration question of the animals pulling in droplets of water with oil in them and sort of getting in there and causing tissue damage, driving some of that disease. And Forrest can speak a little bit more to that. But I think, the volatiles from this particular spill would have been limited to pretty close to where the actual wellhead was. And then by the time you start to get kilometers and miles away, you're really talking about some of the more weathered oil. And then, of course, the burns are a whole nother question. Absolutely.
Forrest, did you have anything to add to that?
Not much. I guess I can add that, again, this highlights the value of the stranding networks and the dead animal samples in these settings to try to figure out what's happening, both real time and then continued over time, because we're seeing continued lung disease and we're over a decade out now, and we still see chronic lung changes. And one of the ongoing projects that we have is trying to figure out what the ultrasound findings over time mean, to try to at least give a little bit of insight into some of those really good questions that she posed. So we're relying heavily on human medicine to try to classify the changes that we, again, still are seeing, which is pretty phenomenal.
Okay, thank you guys. So we have one raised hand. So let me see. Roberto, I think I've given you permission to talk. You have to unmute yourself. Go ahead.
I didn't have a question, I'm sorry.
Oh,
I'm trying to figure this out. Okay, I'm sorry about that.
not a problem.
Thank you.
Sure. Okay. Anyone else have questions? You can raise your hand, apparently, or you can drop your question in the Q&A.
While we're waiting to see if there's any other questions, I have to ask Ryan and Forrest, do you guys have like plans and funding in place to be able to continue to monitor the BV population for the following upcoming decades, or is that to be determined?
What a perfect question, Scott. Thank you for asking. Unfortunately, we don't. It's a real shame, not just because I selfishly want to do research on these really fascinating animals and situation, but a lot of you probably know that the state of Louisiana, as one of their restoration projects, has proposed a quite large sediment diversion project to try to combat coastal erosion. And of course, you know, they have a very difficult job because they have to balance all kinds of different resources, the pros and cons. The pro is that the sediment will bring, you know, some additional wetlands. The con, from our perspective, is that to get the sediment there, you have to bring a whole lot of fresh water into the basin. And based on our work with veterinary panels and with the models that we've run, it is going to be, you know, catastrophic for the Barataria dolphins. It'll be a long, slow, painful death if they're just sitting in that fresh water for these prolonged periods. And so it's really a shame because nobody is in there right now trying to get that baseline data on what the dolphins look like. How is the recovery happening, right? According to our models, this should be where the biggest recovery uptick is happening. And so we're really trying to knock on doors and rattle cages to find someone who's willing to work with us to get back out there and try to fill in this really important gap in time.
Awesome, thank you.
Mike also says that the Gomery program was funded for only 10 years. So that funding has ended, unfortunately. A shame. Okay, am I missing any questions, Deneen, Scott? Have you seen anything else come through? Okay.
So,
well, I just want to thank Ryan and Forrest. Thank you so much for taking time out of your busy days to share this really, really important information with us. We really, really appreciate it. And with that, I will turn it back over to Deneen to close us out.
Great, thank you. And thank you, Ryan and Forrest. That was really fascinating and very important information. And we appreciate you taking your time to join us today and present. And again, we will have a recording available if anybody from the foundation didn't get to come today and would like to see your presentation. With that, just a quick reminder that our final lecture series will be on June 6th from 12 to 1 p.m. And we'll be sending out more information to the network about that and how to register very soon. And we thank everybody for being here today and for all of your great questions and involvement. And we will see you next time.